Hi guys, welcome to this set of videos. This set of videos is really going to go through kind of how we go about reasoning and proving a particular statement. You have probably heard that in geometry, one of the things you have to do is, or we really take a much deeper look at proofs. Being able to justify why we do what we do. Right? And that really kind of makes sense to do it here in geometry. Now, not that you haven't done it in algebra, we do, but more so here in geometry, and it makes a lot of sense. The problems that we've done so far, you've already seen this. In order to solve a problem in geometry, right, it's not just being given an algebraic expression where you kind of step by step go through to get your answer, right? What we've seen so far is you have to know something. You have to know the segment addition postulate. You have to know the angle addition postulate, right? You need to know those postulates, those theorems, those definitions, and you use those to help you set up a problem that allows you to get to your solution, right? And by knowing those things, what you're doing is you're justifying your steps, right? I know I can set this problem up this way because I know the segment addition postulate, right? It's the reason, the justification for doing what you're doing. So it really makes a lot of sense to go more in depth with reasoning and proofs in geometry, because it's really what you're doing when finding a solution to a geometry problem. I've already said enough about it. Let's take a look at our essential question, our objectives, and then we'll kind of jump into reasoning and proof. So here we go. Remember, the essential question is what's really going to kind of direct our learning as we go through. This is the question you should be able to answer by the time we get all the way through this set of videos. And it's simply this: how? How do you go about proving a statement? All right. Now, to help us answer that question, there are several things that we're going to look at, we're going to talk about, we're going to discuss, we're going to learn that'll help you all go back to answering that question. So, we're going to explore, starting off, inductive versus deductive reasoning. They are different. We'll talk about the differences and which one you may want to use versus another, or when it's appropriate to use which one. We'll go over all of that. Then you're going to use properties of equality and postulates, some of the postulates we've already talked about, to write a logical proof. We'll actually look at writing proofs and sort of show you how a certain way of doing proofs. There are many ways to write proofs in here. This particular set of videos we'll talk about the most common one, which is the two-column proof. It's not the only way, but it's a common one and one that you probably will use the most. Students will solve equations using properties of equality and postulates to justify their steps, all right? So we're going to kind of get introduced to this idea of reasoning and proofs. Here we go. Let's jump right into it. Up first, we have inductive reasoning, all right? Here's really the idea with inductive reasoning. Inductive reasoning is looking at specific situations to come up with a conjecture. Here's the easiest way to say this. Inductive reasoning is working on previous experiences or a pattern in order to make a conjecture. And a conjecture is simply a prediction about what will happen. So you're going to predict what will happen based on previous experiences or what you believe to be a pattern. So your conjecture is, oh, sorry, hang on 1 second. I'm not sure what happened. There we go. Sorry, I'm really sorry about that. That was weird. Conjecture, it's an educated guess, right? You're making a guess. In fact, if you want to call it a hypothesis, you are forming a hypothesis based on past events or patterns. It's a statement that you believe to be true. Couple of things here. Let's just run through a couple of these. It'll make perfect sense, I promise you. Take a look at the following. All right, I got a couple of examples here, and let's just see. Let's just see if we can recognize based on previous experiences or recognizing patterns. 4, 8, 16, and 32. Give me the next. Continue the sequence. All right, well, let's look for a pattern based on my experience here. How do I go from 4 to 8? Well, I could multiply 4 by 2. That would give me 8. Does that continue to work? How do I go from 8 to 16? Multiply by 2. Awesome, maybe I have a pattern here. 16 third multiply by 2. So it looks like I've determined a pattern here. You take the previous number in the series, multiply it by 2, and you get the next number in the sequence, all right? So if I were to keep going, 32 times 2, I believe 64 would come next. 64 times 2 would be 128. 128 times 2 would be 256. Based on inductive reasoning, looking for a pattern, I believe, my hypothesis, my conjecture, is that these would be the next terms in that sequence. All right, great. Let's do it with this one. I have a triangle and then a square. I have 2 triangles and then 2 squares. What do you think comes next? Based on the pattern, I would say probably 3 triangles, 3 squares. My conjecture is that will be the next set in this series based on a pattern that I've recognized, based on previous experience. 1 triangle, 1 square. 2 triangles, 2 squares. 3 triangles, 3 squares, right? It's a great guess, but it's an educated guess. I'm guessing, okay? I got a couple more for you here. Write a conjecture, a hypothesis, given that AB is equal to CD and CD is equal to EF. Well, look for a pattern here, right? What's going on? I'm going in alphabetical order. A, B equal to C, D. C, D equal to E, F. So I would then, my conjecture is E, F equal to G, H, right? I just keep going in alphabetical order. G, H equal to I, J, right? So just keep going. My conjecture, my hypothesis. Could be true, maybe it's not. We'll talk about that in a second. Write a conjecture given the points A, B, and C. Now, just looking at the points, really hard to find a pattern. What I would suggest is that you would plot them, graph them. A, -1, 0. There's A. B, 0, 2. There's B. C, 1. Now, can I find a pattern? Well, to go from A, I went to the right 1 and up 2. So over 1 and up 2. To go from B to C, over 1, up 2. Okay, so what I think I found here is a pattern, which means then that D, point D, would be over 1. That's 4, 5, 6. And up 2. So over 1, up 2. My conjecture is that D is right there, which is at 2, 6. So I believe that D is at the point 2, 6, based on the pattern. Now, just looking at the points, you probably wouldn't recognize that pattern. Really tricky. That's fine. Graph the point, especially if you're given points or a graph or something like that. Graph it. Pictures are visual representations are almost always easier, all right? So please draw a picture. Now, when it comes to inductive reasoning, I have made a conjecture. This is what I believe to be true, okay? I'm making a statement that I believe to be true based on previous experiences or patterns that I see emerging. I'm making a prediction, a conjecture. How do I show that a conjecture is false? I've made a hypothesis. How do I prove that it's false? It's very simple when it comes to proving by inductive reasoning that something is false. You're simply looking for a counterexample, all right? And this is the way, right? Using a counterexample, it is a counterexample. It's the opposite of what you're trying to prove. Super easy. Let me say this. Driving to work today, the first 5 cars that I saw were black, right? The first 5 cars that I saw were black. So my conjecture is that the next car I see would be black. Okay, so think about this. Inductive reasoning, the pattern. First 3 cars I've seen driving to work today were all black cars. Based on that pattern, based on my past experience, my conjecture by inductive reasoning is that the next car I see will be black. But is that a true or false statement? It depends. The 4th car I see could be black. It could be. But if the next car I see is red, then my conjecture is false based on the counterexample. The 4th car I saw was red, not black. So inductive reasoning is an okay way of proving something, but you can show that your conjecture is false with just one counterexample. All you need is one counterexample and the conjecture is false, okay? So, stick with me here for a second. The next kind of reasoning, or the way of proving something, is what's known as deductive reasoning. Let me go ahead and highlight this for you. We'll talk about what deductive reasoning and then kind of the differences between the two. Deductive reasoning is a process of reasoning logically using facts, rules, definitions, properties, postulates, right? To reach a conclusion, okay, that is true for all cases. And here's the reason why. If the facts, rules, definitions, or statements are true, then deductive reasoning produces a true conclusion. If all of the facts that you're using, if all of the conjectures, all the theorems, all of the definitions that you're using are true, and you use those to prove something, then what you're proving must be true. Okay, must be true. Think of it like this. Let's go back to that example I just gave. I'm driving to work. The first 3 cars that I see are black. Inductive reasoning allows me to make a conjecture. The next car I see will be black. Could be true, could be false, right? If the next car I see is black, my conjecture was true. If the next car I see is red, counterexample, my conjecture was false. That's inductive reasoning. Here's deductive reasoning. I'm driving to work. The first 3 cars I see are black, all right? But here's what I know, all right? It's the 1920s. Henry Ford is pushing Model Ts off the assembly line. And one of the famous sayings for Henry Ford with his Model Ts coming off the assembly line was this: you can get the Model T in any color you want so long as the color is black. All right, they all came in the same color. They all came in black. So let's say I'm driving to work. I know I'm driving through a dealership that sells Model Ts. Every Model T is black. It doesn't come in any other color. So I'm driving to work. I see 3 black cars. Inductive reasoning says the 4th car I see will be black based on my previous experience, right? If I see a black car, conjecture was true. If I see a red car, counterexample, conjecture was false. Inductive reasoning says, based on the fact I'm driving through a dealership, a fact I know, I'm driving through a dealership, and another fact, that dealership only sells Model Ts, and Model Ts only come in the color black, right? First 3 cars I see are black. Deductive reasoning says the 4th car I will see will be black, because they're all Model Ts and they're all black. Here's another great way to think of inductive reasoning versus deductive reasoning. You are a homicide detective. You've just been promoted to, homicide. You've only been on the job 6 months, right? You're a homicide detective. And in those 6 months, you have seen 3 homicides, all right? 3 different homicides, okay? In each of those cases, the 3 previous homicides, in the 6 months you've been a homicide detective, those 3 previous homicides have all been a husband who has been found dead in his home, all right? Murdered in his home. Now, in those 3 previous cases, in the 6 months you've been working as a homicide detective, in all 3 of those previous cases, the husband was murdered by the wife, okay? So, you're a homicide detective. You've been on the job 6 months. You only have seen 3 previous homicide cases. The phone rings. You pick it up. Hello, this is Agent Lawrence. What can I do for you? Hey, we got a homicide over here. Can you come check it out? Yep, awesome. I'll be right there. Hang up. You drive over. You get to the scene, and it's a husband who has been murdered in his home. All right? You've been a homicide detective 6 months. You've only seen 3 previous cases. In all 3 cases, the husband was murdered by the wife. You pull up a husband found dead in his home. Inductive reasoning based on prior experience, a pattern. Inductive reasoning leads you to believe what? Number 4, the husband murdered in his home was murdered by his wife. So inductive reasoning would lead you as a homicide detective to what? To first suspect the wife murdered the husband in their home. So what do detectives do? They bring the wife in, right? The wife is going to be the first person of interest, the first person that they're going to talk to. Why? Because based on previous experience, it was the wife who did it, right? But you bring the wife in. You're interviewing the wife. She has witnesses who can, collaborate her story, right? The wife was with the kids visiting her mother in another state when the husband was killed. The wife now has an alibi. Inductive reasoning based on previous experience tells you the wife did it. Your conjecture is the wife did it, but based on further evidence, you now have a counterexample. The wife has an alibi. She wasn't even in the state. She couldn't have done it. So the counterexample says it's not the wife. Inductive reasoning is out the window. Your conjecture is false based on a counterexample. So why do we call them homicide detectives? Well, not only do you generally use induction, but deductive reasoning, right? What the homicide detective is going to do, they're going to look at the facts, the evidence surrounding the case. You check with the wife first, right? Because most of the time it's the wife who did it. But in this case, the wife has an alibi. So now maybe you start searching into financial records, right? What you find is the husband was in business with a partner. You find out after checking the financial records that the business partner has been embezzling money. The husband found out about it when he confronted his business partner. Instead of being caught and going to jail, the business partner murders the husband, right? And so now with a little bit of more evidence, checking the facts, deductive reasoning, with more information, you are now able to conclude that actually the first three cases, it was the wife that did it. But now in this fourth case, based on the evidence, right, you can show that the business partner had probable cause for the murder of the husband, right? So the difference between inductive and deductive reasoning: inductive, you make a conjecture, a counterexample will prove it false. Deductive reasoning is based on the facts, the evidence at hand. As long as all the facts are true, then the conclusion that you come to should also be true, all right? So head on over to the next page of the notes, because actually what we're going to do here, I'll come back to in a second. I am going to jump to the next page. We're going to talk about conditional statement real quick, and then we'll come on back. I'll meet you guys over there.